Imagine teaching a robot to play chess. You could code every possible move, but chess has over 10,120 possible positions. Impossible. Instead, what if you let it learn by watching you play? That's the power of inverse reinforcement learning, a method where machines infer goals from human behavior, not rigid rules. But here's the challenge. What if the human isn't perfect? That's where a groundbreaking technique called Splash steps in. Let's unpack this. Traditional AI systems assume human demonstrations are flawless. Think of a self-driving car learning from a tourist's shaky navigation. Should it copy every wrong turn? No. Most models treat DMOS as gold standards, but real-world data is messy. Splash changes the game by focusing on preferences, not perfection. It's like teaching a robot to cook by watching a chef, but also recognizing when they fumble, figuring out what makes a dish good, not just replicating every step. Here is how Splash works. First, smart sampling. Instead of trying to memorize every detail, it identifies the most critical moments in a task. Like a chef focusing on seasoning rather than the exact time they stir. Second, preference learning. It compares two actions and learns which is better, like choosing the smoother path on a hike. Third, adaptive rewards. It dynamically adjusts its scoring system, getting harder as the robot fails, pushing it to improve. Finally, consistency checks ensure the robot doesn't flip-flop between strategies, like a musician practicing a song until it sounds seamless. The results? Researchers tested Splash in a simulated game of Capture the Flag with autonomous boats. Even when given flawed human DMOS, the AI outmaneuvered opponents, adapting like a seasoned player. They even tested it on real boats, proving it works beyond the screen. Why does this matter? Imagine a robot learning to navigate a city by watching a tourist, or a warehouse bot picking up tasks by observing a human's messy but effective workflow. Splash bridges the gap between human imperfection and machine precision, enabling systems that learn flexibly, efficiently, and from real-world data. So next time you see a robot doing something smart, remember, it might have learned by watching you, even if you didn't do it perfectly. Thanks for watching and stay curious.